if you want to take a seat. Cool. Hello, everyone. Welcome. Oh, the first in-person Cloud Native Meetup. I'm really happy to see everyone here. A lot of faces that I don't know, so that's also nice because the meetups are for that, for network, so welcome. If you do not follow us, we have a community page on CNCF, community.cncf.io/links, and that's our Twitter handle. So if you tweet something about today, please tag us. That's the agenda, but we got some issues. So I'm starting with the welcome, and Jürgen was supposed to give the talk about Captain, and he got an issue, and he will not be able to join us. Instead of putting him on the virtually here to present to us what wouldn't make a lot of sense, as we are like finally in person, I said, yeah, I can cover to you, and I'm changing the topic. So even being with the Captain hat, I'm not a Captain expert, so I don't feel comfortable in giving a talk about Captain. So I'm gonna talk about OpenTelemetry and Dynatrace. Just as Dynatrace is sponsoring the event, so we can have that opportunity. Then we go to the Philipp's talk. Philipp is from Microsoft, so we are really happy to have him here. And after that, we have some snacks. We can continue drinking and doing some networking. Before I forget, at the back, we have a desk there with some stickers, some swags from Dynatrace, stickers from Cloud Native, and yeah, that's it. But I also have some other stuff to raffle, so depending on how we go and questions and stuff like that during the presentation, we see how we can give that. So we do have 2 shirts from Microsoft, a box from Cloud Native Foundation from KubeCon last year. So it's nice to finally give away that. So we, as part of the Cloud Native Computing Foundation meetup, we follow the code of conduct from CNCF. We have a huge QR code here if you wanna take a look at the whole code of conduct. But basically, everyone is welcome. It doesn't matter your level, your gender, where you're from. Basically, everyone is welcome. So that's what we try to be a welcoming community and a welcoming meetup. The organizers are myself and Jürgen. So I'm a software engineer at Dynatrace, and Jürgen is a Captain evangelist. So it would be awesome to have him here to talk about Captain. Yeah, but those are our Twitter handles. So if you want to follow us. And yeah, so Dynatrace is hosting us and also providing some snacks and drinks. And if you don't know Dynatrace, just ask for the guy on your side. No, just joking. So Dynatrace is a intelligence platform. I told Lisa that I don't know how to explain Dynatrace to my friends because we do so many stuff. And she said, yeah, just tell that we do a lot of stuff. And yeah, but I'll not tell that. So basically, with Dynatrace, you can monitor your whole application, your whole ecosystem, and it's pretty awesome. Before joining the R&D team, I was part of the Dynatrace 1, where we do some enablement for customers. So I do know a lot of the product, and that's why I don't know how to narrow down what we do, because we do a lot. But like from tracking customers' transactions from the click of the button till your methods being called, in your backend, database calls and everything. And also we have Davis, our AI engine, that is super awesome and predicts some issues that you may found in your environment. So, before I forget, we are hiring. I know we have a lot of Dynatrace people here, but for the ones that are not from Dynatrace, yeah, it's good to know. Cool, important stuff. If you would like to present, so that I was discussing with Philipp before, and that's one of the things that I like from meetups. As we have a smaller audience, it's awesome to practice some talks. So if you are working with something for the last couple of months and you want to try it out, being in front of people, practicing, talking, and working on a presentation, use the meetups for that. And if you are working with something related to cloud native, ping us, and we would love to have you. As I mentioned before, you are most welcome, and we are a welcoming community. Also, if your company would like to have us, as Dynatrace is having us today here, you can also check this QR code to register and have us maybe host our next meetup. And if you want to keep the discussion going on, and not just for the 2 hours that we will be here, join us also in Discord, also a big QR code, but we have the tiny URL there. And if the recording is properly set, this will be online afterwards. And yeah, perfect. So today's speakers is me. So I'm Juliano again, and then afterwards we move to Philipp. As it was pretty in the last minute, I have something that I'll try to keep short. And yeah, so hopefully everyone enjoy. Perfect. So I'm going to start talking about OpenTelemetry and how we can use OpenTelemetry in Dynatrace. Of course, I forgot, but just to show to everyone and to the ones who don't know, OpenTelemetry is an observability framework for cloud-native software, and they have a lot of they cover a lot of technologies. And the idea is to be agnostic, so not vendor locking. And that's what is cool, because OpenTelemetry is a project maintained by Cloud Native, CNCF, and I'm gonna show in my talk how we can take advantage of OpenTelemetry and enhance what we already have in Dynatrace. So you see here that we have a couple of technologies, but the coverage of OpenTelemetry is huge, and we have a lot of cool stuff from the community. Perfect. So then here I have a currency API that converts currency from one country to another. So basically, I have this endpoint convert where I send a currency code, in this case euro, and I send a value and the units in nano that I want to convert and the currency that I want to convert. So for instance, I want from euro to USD. Then I send a request and I get that 10 euros would be $11 and those nanos. So pretty basic stuff, simply a post request with that information. Cool. So I have, of course, my application monitored by Dynatrace. So whenever I jump into Dynatrace, I have my host here, and we see that we have here processing containers on the right side. And we see that we have a couple of technologies already detected, and we have this currency converter currency converter Node.js. So whenever I go to this and I have my service, that would be my my code level. And when I go to my service, I see that I have some data from my service. So response time, failure rate, CPU, throughput, and I can check what we call pure paths. And in these pure paths, so this is what this is where I have a mock-up for you, because as I mentioned, I got this presentation at the last minute. So I already have here what we would have without OpenTelemetry. So that's Dynatrace monitoring my application. So I have a request arriving at convert, and this convert my Node.js application calling a Python currency API conversion rate from a specific currency to another. And if I go to my Node.js, I have a lot of information here from my node, and like some metadata, some request header. And if I go to my code level, I have a couple of data regarding my code. So as I mentioned before, we can go into the method that I'm doing, the method that I'm calling. And that's pretty cool. For Node.js, we do have a code module. That's what we call. So that's why I get that much information. For Python, though, we see here that the code level tab is gone, and we have just some couple of information. So like I have my URI, I have my response status, but I cannot, I don't know further, like, is this currency API giving the response to me? Am I calling something else? What else can I get? So if I jump to my code, here, so I have here my currency API, and it's a pretty simple app. Yeah, I think the font is nice. And we see here at the bottom that we simply have this endpoint, conversion rate, and this, whenever we get a request from here, we do a call to an external API. And this external API is here at the top. Without having access to the code, we wouldn't know about that. Well, of course, that without knowing, without having access to the code, we wouldn't be able to instrument with OpenTelemetry as well. But as we have, and we know OpenTelemetry, we can come here and add a couple of dependencies. So like here, I'm simply adding the trace and then exporter. So the exporter will be the responsible for sending the trace to somewhere. And here I use Flask as a framework for my Python app. I also do I also use requests to call the external API. So I use the Flask instrumenter and the request instrumenter. And so like resource, just to give a resource name, tracer provider, just to create my tracer, and the batch span processor to send the spans in batch. So that with the Flask instrumenter and the request instrumenter, that will already tell OpenTelemetry to instrument my app, and whenever there is a request to my conversion rate, generate a traffic span and send to the endpoint that we configure. Here at the top, I have a span exporter configured. So that's my hotel collector. I will talk about the hotel collector in a second. But with that, when I run my application again, so again, just using what I already had. So with that, whenever I run my application again, you see that now I have my convert request. This goes to my currency API, and I have two OpenTelemetry spans being attached to my Python application. And in here, we can have a lot of further information. So we have a lot of metadata and a lot of what OpenTelemetry call span attributes, and in Dynatrace is attribute. So like here we have a lot of attributes, and you can see that we have a lot of value not stored. For security reasons, Dynatrace do not store the attributes by default, but we can simply configure in the allow list to get some values. So I already configured the HTTP method, status code, and URL. So we see that we have there, and also some resource attributes with the name of the service that I gave. So like we enhanced our peer path. And what is also cool, we have this HTTP GET, that is the request to the external API, and now we have it here. So like whenever we have an issue with this external API, now we would see in our peer path that the failing request is happening here. And once we have all that data in Dynatrace, Dynatrace can do all the magic that we are able to do. And track that, alert on that, create some request attributes on that, and you can create charts and everything. Cool. What else can be done? So like, the only thing that we have here that tells the currency that the user is calling is our URL. So like, I know that in this case, the user is converting euro to euro. Awesome. So yeah, perfect conversion. But besides that, I don't know what was the response, what is the value that is returning. So let's say that I want to extend what we already have in the Node.js. So I will just switch here to my currency converter, and I'll not discuss about this app a lot, but here at the top we see that we add the tracer and the span kind. That's from OpenTelemetry. And here at the bottom, whenever I get the convert request, I call my convert method. And whenever I arrive here in my convert method, I'm creating a manual span. So like I'm using OpenTelemetry to say, hey, I have this and I want to create a manual span. So the name I gave. And here I can add some attributes. So I'm adding what is the currency that the user is sending, what are the units, the nanos, and to what currency he wants to convert. And then I do the request. And once I get a response from my conversion rate, I also add here at the bottom the factor, the result in units and nanos. So like I'm adding all the information that is coming from the API to OpenTelemetry. And then whenever I switch to Dynatrace again, and then I would have an extra node here. As we can see, so the request arrived at convert, the manual span was created, and whenever we go to the manual span, then we have the same approach that we had before. We see that we have some value not stored, but I can configure that. But here we can see that the user sent from Bitcoin to Egyptian currency. I have no idea what is the Egyptian currency, but yeah. And that's the factor that it got. So yeah, I extended all the information that I was getting from all the information that I already had in Dynatrace with OpenTelemetry. Just one thing that I forgot to mention. If I go to my currency converter, we see here that I create my span manually, but there is nothing in my code telling to where to send that span, as we have in Java, in Python. So like in Python here, I have my span exporter, say, hey, send the spans to that endpoint. But in here, I do not have anything. And if I go to my tracer class, I also don't have anything. So those are the two classes that I have. So as I mentioned, a super simple app. And there's nothing related to where to send and how does that happen. So as I mentioned, Dynatrace has a code module for Node, and we inject ourselves into that. And as we support OpenTelemetry, whenever we find OpenTelemetry stuff in the code, by stuff I mean spans, attributes, and everything, we get that data and send to Dynatrace automatically. So the customer, he doesn't need to configure any API token, any endpoint, anything. So just having the application monitored by Dynatrace, we will do the magic. Different than the currency API, where we need to specify. So in this case, we do not have a code module for Python, and we say, hey, send the span with OpenTelemetry to this endpoint. And this endpoint is another service from OpenTelemetry that is called collector. And in this collector, I can specify, hey, you have a receiver. That receiver can receive OpenTelemetry protocol traces or spans in gRPC and HTTP. Whenever it gets it, I want to process this as a batch. So in the same way, I will not send one span at a time. I will grab a couple of them and then send at once. And to where I'm gonna send, and then here I have the exporters. And here is where I configure Dynatrace. So those, well, actually for Dynatrace it's just 2 lines, but those 4 lines. So I'm saying, hey, whatever it arrives in the receiver, send as OTLP HTTP to this endpoint. And in this endpoint, I would have my API endpoint, like TSJ, blah, 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 /API, /v2 OTLP. And I would also have my API token, because then something from outside, it's coming to Dynatrace, so it needs to be authenticated. Then at the bottom, I just define my pipeline, and I say, hey, those are the receivers that I have, processors, and these are the exporters for the pipeline of trace. OpenTelemetry also has logs and metrics. Dynatrace also works with that, but I've been working with traces, and I just focused on that for the presentation. And yeah, that's it. Thank you very much. Should we do a Q&A at the end?
You can do Q&A while I
okay.
switch over. And then
Any questions?
Is every trace sent, or is there a configuration where you need to send every 10th request, or is every request traced and stored?
You can configure in OpenTelemetry in the processor, or in the processor. Yeah, you can configure sampling.
Okay, sampling rate.
Yeah, so not all the requests are sent, and then yeah, that would help a lot your network. Yeah.
Just whether I understood correctly, but OpenTelemetry defines an interface and provides an SDK, which I can include, and Dynatrace consumes But the code is pretty much independent of Dynatrace.
Exactly. That's the magic, actually. The idea of OpenTelemetry is to be agnostic, so you can instrument your code, and I think what is the most valuable, I would say, part is that you can configure always to send to a collector. So you instrument all your microservices, everything that you have, and that will be always the same, and you send the data to a collector. Then, if one day you decide to change from one vendor to another, you just go to your collector and send the endpoint that the data will be sent. Problem solved, one change, and yeah. If you're changing to Dynatrace, you'll get a lot more, and if you're changing to somewhere else, then I don't know.
Does the collector store the data?
There is a configuration for the exporter to export the spans into a file.
Yeah.
So instead of sending to somewhere, it stores in a file.
So if I use the Elk stack, Elasticsearch, and Kibana at the moment for storing my OpenTelemetry data, could I just switch to Dynatrace?
Yes.
Have the same experience.
Mm-hmm. Exactly. And if you are using the collector, you can even say, hey, whenever there is a request arriving here, send this same data to Elastic and Dynatrace. So like you can, I'm doing in my collector, I didn't go through, but I'm logging and sending to Dynatrace. So I can see my console that is working, and I also can see the spans in Dynatrace. So you can kind of duplicate. Cool. Thank you very much, Philip.
Perfect, thank you. It's working. Great. So, after tons of lines of code, let's step a bit back from code, I guess. And what I've been asked to do, yes, is to take you on a journey into the 1001 serverless options you have in Microsoft Azure. Guess what? I'm from Microsoft, so I have to talk some kind of product. But really the goal is to give you a bit of an insight, given it's a cloud-native foundation, cloud-native meetup. So cloud is in the name, so I'm not that wrong, I guess. So what I wanted to focus on is serverless options, because I think that's, first of all, a term that is heavily used. And if you ask 3 people, you will get 4 descriptions of what serverless is. By the way, despite I'm from Vienna, I was asked to present in English, so you have to thank him for that. But before I dig into the actual options in Azure, I wanted to kind of put us all on the same page what serverless is, right? So I took, out of my vast repertoire of hobbies, I took 2 out of it because I think they make up a good analogy of what serverless is. And maybe you can guess which ones those hobbies are. So if we talk about software development in general, right, there is the random technology sea of stuff. Could be deployment options, could be frameworks, etc. And every techie likes to pick and choose from these different options, disappear in the basement and build something. But in reality, that might not be the most productive way of doing things, right? So with cloud vendors like Microsoft and others, there's only one real one, but the other ones are good as well. We have taken those random technologies and kind of streamlined them, right? So giving you options. What are you pressing? Oh, okay. Giving you options to build up infrastructure, to use services in the cloud. But really those infrastructure services are the ones that are considered more or less basic, I want to say, right? Networking, virtual machines, etc. But the real power of cloud applications comes from higher level services, higher value services. And this is where serverless comes in, right? Building blocks that you can use to build applications faster, to deploy applications faster, but still allowing you to let your creativity run wild. Because in the end, nobody's gonna give you anything for being the one person that builds a house out of cement if you could have used bricks, but could have been much faster. So I think that's the whole idea behind using serverless technology. And with serverless, that's why I deliberately crossed out the bottom one, because I guess we're all engineers, right? So we all know that it's not serverless, it's just less server that I need to deal with, right? There's always has to be some kind of something that runs it, it's not magic. So to use those building blocks to get where I need to be faster. So now that we are on the same page what serverless is, let's look at Azure. What does Azure have to offer? And usually when people talk about serverless, they talk about running code in the cloud with some kind of magic thing, like functions, or running a container in the cloud magically. But in reality, if you look at it, it's much, much more than that, right? Because there is much more options in Azure that you could consider serverless, because you'd literally deal with the service rather than the compute behind it. Personally, I like to kind of separate those two serverless, those services into two buckets. One is the ones that are more deployment and runtime oriented, and one are the functional services, if you want, right? So if you look at the deployment and runtime services, the first option could be pipelines, right? I'm writing code, I want to build my code, I want to make it deployable. So I could set up a whole pipeline, I could set up build servers, I could host them in my own data center, or I could just use serverless options with, for example, Azure Pipelines or GitHub Actions, where I don't have to set up a build server. I just tell the thing, this is my code, this is what I want to get, do it, period, right? Perfect example is with Azure Pipelines, for example, you could say, yeah, I have my machine, this thing can build it to an EXE, or it could build it to a container. Well, what if you're developing, for example, a mobile app for Android and iOS? Well, to develop it on iOS and to deploy it on iOS, you need an iOS machine. But you don't necessarily have to build it on iOS if you use some generic frameworks. So you could use a serverless build machine that is an actual macOS machine to build your iOS application without ever having to touch an iOS machine, right? So this is kind of the first step in serverless. And then when you go down the list, these are the traditional ones, right? Running function code, running a container serverlessly, running web applications, running workflow style applications with logic apps, for example. And then when we go down even further, that's where kind of traditional compute and kind of cloud native compute meet. It's basically containers, right? What options do I have to run containers in the cloud without having to deal with setting up a Kubernetes cluster or setting up some kind of container runtime? Well, I could use container instances in Azure, I could use web apps, container apps, or I could use a managed Kubernetes cluster, right? Who has set up a Kubernetes cluster in their spare time? How long did it take you? 5 hours, more than 5 hours. For one, okay? So I can tell you it takes me 15 to 20 minutes with a managed Kubernetes cluster. It's basically one command, you submit it, and 20 minutes later you have a running Kubernetes cluster. Not bad. If I want a production, I could say it's okay for a production machine or a production cluster that's going to run for years. I can spend 5 hours or 10 hours or 20 hours. But if it's my development cluster that I bring up, cut down, bring up again, spending 5 hours every time I need a new cluster, that's a waste of time. So why not go with the managed service serverless options? And then if I go over to the more functional services, we are in the high value things like database services, managed storage, etc. Or if we go one step further up, messaging. service buses, etc. All concepts that have been around for ages, but who has ever set up a service bus environment on premise knows the pain and feels it. Setting it up in a managed serverless way, you just say, I want a service bus, I want a message queue. A couple of minutes later, you have one and can use it for your development. And then if we go all the way up to the highest levels, things like API management or things like cognitive services, AI services, things like IoT services, etc. At that point in time, you actually get quite a bit of functionality inside your package that you can just use in your application. So you can see that going from no code to running application, using those building blocks, you can get there much faster. This is an overview of Azure services in general. And that's a public website. I have the link later on. So that lists up all the different services based on different kind of categories, each color being a separate category. And with cloud providers, you usually hear things like platform service or PaaS services. Those are the ones that you can generally say those are serverless things, right? And within Azure, out of the whole list, a quite large number are actually considered these kind of platform services or PaaS services. And they can be as simple as an Azure function, right? Simple code running in a serverless environment. Or it could be as complex as a runtime environment like Kubernetes, or where do we have it? OpenShift, managed OpenShift, or Spring Cloud is somewhere. So high value, highly complex runtime services that are all more or less deployed and provisioned within a single line of code. You can make it more complex as well, but the easiest way of going there. So if we take a couple of examples, let's go back in pre-corona times. 2019, when Jamstack was the latest and greatest, right? So for Jamstack, what do I need to run a Jamstack application? Well, I need some kind of storage where I have my static content, whatever framework you like. And I need some kind of runtime environment where you have your APIs. So in Azure, we have these already. So we have managed storage, and we have Azure Functions. So I could build a Jamstack application very easily deployed within, again, a couple of lines of deployment code, and it's going to be running in Azure. Still, you kind of need to make your way around certain rough edges in this combination, but it generally works quite well. But in Azure, there is actually a separate service, because what I really want to do if I write a Jamstack application is I have my code somewhere, I check it into my source control, I run the build pipelines for whatever framework I'm using, and in the end, I want the stuff be deployed for the API and for the static content without me really dealing with how those two work together. And that's a service, it's called Static Web Apps in Azure. So it's a purpose-built serverless environment for Jamstack applications. Could be React, could be Vue, whatever. So why would you bother if you have the other two options? Well, because this one, besides the fact that it's purpose-built, it has additional bells and whistles that you can use. Because once you have your application on there, it still includes behind the scenes the two at the top, right? The storage where my static content is and the functions where my APIs are. But without any additional work, you get things like authentication. So if your app wants to authenticate against Facebook or Twitter or Microsoft, it's just a checkbox, basically. You get CDN, you get deployment slots, basically. I mean, who has created web applications, checked in source code, created pull requests, then you need to have the logistics of, okay, if I want to have like a preview thing of my pull request to make sure it doesn't break, you get that for free, basically. So whenever you create a pull request in your source control, it will create a separate instance within your app that has just the code that's within the pull request. And you can test it, and based on that result, you can just scrap it, or you can commit it and accept it, and it goes into production. So these are functionalities that you get more or less for free, well, not for free, but without any additional work. Actually, this one you get for free, basically. Yeah. So let's take a quick look at the web apps just to go back to your, yeah. It's not as big as your text, but I hope it still works. So just to give you a bit of an overview, right? This is basically the source of a very, very simple, literally a hello world simple application based on Vue.js. It just prints out a line of text, and then it calls an API and gets text and overrides basically the text. So in my source code, what I have is down here, I have my Vue.js source, and up here, I have my API code, which is simple Node.js code, which just returns a stupid line of text. So if I go here and let's make a change to my code, and then I just go in and say, well, great, I'm done. Yay! And I check the code into my GitHub repo. What happens behind the scenes, you basically get when you set up that environment. So what it does, it has a pre-built GitHub action that basically does build my Vue app, because in Vue you have to kind of process it to get from your pseudo-static to your actual static files. Then it deploys the static parts to the storage, the API to functions, and then gives you a ready-made or ready-to-access application. And now if you look at my actions, you see the action is running. Another part of serverless, right? This is not running a build machine on my laptop or build on my laptop. This is running in the cloud. This is running serverless in GitHub. So I don't have to worry about setting up a Vue environment and making sure that I have all that shit installed. I just deployed. GitHub has the build machines hosted that you can use. And after however many seconds GitHub decides to use, we're going to have an application running. And we'll quickly switch to the application so I can show you a couple of aspects of it, right? So this is the application. Right now in the background, it's deploying and pushing stuff in. But all the things you see here is basically what you get as part of the package. You get things like custom domains, right? It's not bad. If you want to have your application be on a custom domain, you just register the domain, the service gives you a certificate, you're good to go. If you want to, where do we have environments, right? This is what I mentioned earlier. You have production environments and you have staging environments. Staging being the pull requests. So if I were to do a pull request in my pipeline, it will not change main, it will actually pop up with a web app instance with a dedicated URL that you could use to test your code changes. So let's double check on the pipeline. Look, it's done. So if I go here and run the application, here's my change, right? So a very simple application. I'm very proud of it. But basically, I have not touched any kind of server and runtime environment, nothing, right? All the thing does, it detects what framework I'm using. Based on the framework, it decides what build machine to choose on GitHub, and then basically deploy it to Azure. And best of all is this. If I go here and check the hosting plan, look at that. Not bad at all, right? I mean, I'd much rather prefer you to use this one, but it's not bad either, was it, right? So you could basically run applications, test web applications. Even if you don't want to run them in production, you could use these frameworks to test them in development, right? So, moving on. That was a very simple thing, right? The web application, Jamstack. 2 years old, nobody cares. But in reality, if we look at what requirements we're getting for applications, us engineers are torn, right? It's I really want to play around with that pure piece of technology. But in the end, unless I'm at university, there's always somebody behind me saying, this needs to be done yesterday, and it needs to be basically be able to do anything I want. So you always have the pressure to get faster in development and have even more complex feature sets in your application. So going back and saying, taking a step back and saying, okay, what do I really need to have to build? Or which pieces can I use in terms of serverless services to get where I need to be faster and maybe even overachieve in terms of capabilities. So the biggest problem there is there's so much stuff to choose from. So what could I choose? I've taken a simple example here. Again, application. I have an application, perfect, and now I want to deploy it. So I could use traditional code deploy. I know we're cloud native here and everybody's container, but there are still people deploying code to a server, right? So again, web application. Let's take the Dynatrace application, right? There is a server infrastructure with hopefully CDNs and hopefully some kind of API gateways and hopefully some kind of security, and all that shit needs to be managed, and then there's a big IT that runs that stuff, right? Or you could see what platforms you have in the cloud to run it from. And in Azure, it's called App Service. It's a bit misleading because it does more than apps, but it's basically a runtime environment that you can take your code, deploy into, and all you need to take care of is give it a GitHub URL, a GitHub repo, and it pulls the code from there, deploys it, gives you a web-facing application. You can enable security, CDN, all these nice things, basically by the press of a button. It's not bad, not that cloud native though, right? So since we're all cloud native, it's all containers, yay! So containers, great, but what do you need for containers? Well, you need a registry where you host your container, because then you have some kind of runtime that pulls it from there. Well, guess what? Container registry, serverless. Yeah? Deploy it, push your container from your container framework of your choice, Docker for me. Docker push, I don't need to learn anything. I just say push to that repo, and it's hosted there. From there, I can get more choices. I can choose, well, I could go app service, but app service has two flavors. One is runtime based and one is container based. So runtime based, we said code, repo, run it. Container, it just pulls the container from the registry. Everything else is the same. So managing it is the same. Enabling CDN is the same. Enabling security is the same. Yeah? You can just choose, I want to do code-based deployment or container-based deployment. But that is more kind of a black box, if you want, right? There's a lot of functionality in there, quick deployment of a web-facing application, but it's a black box. Some people don't like black boxes. They like to get their hands dirty. Next level down is container instances. That's a pure container runtime. No bells, no whistles. You run a container in the cloud. It gets exposed if you're internally or externally, the way you want, the same way you were to run it on like Docker run on your machine. And last but not least, the big kahuna in the room, Kubernetes. Right? But it's also a managed Kubernetes service. So you can imagine actually having all these involved in your dev lifecycle. Because to test my container, I don't necessarily need a dev Kubernetes cluster, unless I have like a microservice, huge infrastructure. If it's just a matter of testing a container, I could use container instance. If I have a quick and dirty web app in a container, that might be overkill. That could be good enough. And I still have things like firewalling, port limiting, etc. So, burden of choice. Let's take a look how we can ease the burden of choice. For that, given the time, I'm not going to do the development, create a container. You have to trust me that I can just push it to container instance, right? But in reality, I wanted to show you, I have a container, and I want to have a, where's my folder? Let me just quickly close this. There it is. So I have a container and I want to expose this container as an application via an IP address and a port to the internet. That's the command. Submit this command. A couple of seconds later, you have the container running. So if you look at my container instance, and everything is good for me, and demo gods are not killing me there. I have a container running at this IP address, but it's a pure container. So that container actually is exposed at port 8080. The Node.js application, it's the hello world thing again. So this is basically not working. Why is it not working? What the hell? See, that's what I meant with demo codes. I don't like them. Ah, you know what? Maybe I messed up. Let's try to restart the container. Maybe it's just stale. While this is starting, again, this is the pure container running at port 8080, which usually you wouldn't really want to, right? You have a web application, you want to expose it to 443 or, God forbid, port 80. That's exactly what app service does. So in app service, I have this whole web application framework that surrounds my container. Let's see if that other application is running. Where is it? Here it is. This is all the functionality that I have with app service, but in reality, what it has here is, where is my container? Deployment center. Let's see if we see my container settings here. Yeah. So what I've done is I've basically, this is my registry, my personal one that I've created. I point it to a demo container, the thing pulls it, but it actually hides the container behind that web application runtime. So it only exposes port 80 and port 443, and then gives me whatever the container does. But I could also add bells and whistles, right? I can add access restrictions. So if I say, okay, I only want to access this application because it's a Dynatrace launch menu, I only want to access it from a Dynatrace campus, you can put the access restrictions there based on IP. Or you could say, I actually want this whole application only be available from the internal network, assuming that you have a connection to Azure from the internal network. You can add a CDN basically by the check of a box. So the container is the same, it just runs in a different runtime environment. And so now, let's try again the other container to see if it's actually running. If not, then we'll move on. Nobody has seen any problem then. Let's see. Oh, that's fun outside. Okay, it's still doing. Maybe it's still starting. Okay, let's move on. We don't have time for that. So really, to choose any of those options is not a matter of completely branching off where you're going. You're basing it all off the container. But again, everything is running inside serverless services, so you don't really have to think about how to do it. You just need to think about where to do it. So pivoting that whole picture a bit, as I mentioned, all those options might be actually something you want to build into a development pipeline. You build something, you test something, you build something, you test something, you get errors, you test something, and at one point it gets deployed maybe to a staging environment, or you build something frantically trying to meet the deadline for MVP, and at one point MVP gets rolled out, the pipeline gets executed, etc. You could use different types of environments to deploy, right? You could say for the first day 0 MVP, we do it on app service, we just deploy the code, we have an API and functions, but we only want to do at the code level. And then for day 1, we actually package everything up in container, but we have the API still in functions. And then day X, or to scale up, we take everything in containers and push it onto Kubernetes. And we actually have customers that build these kind of life cycles into their pipelines. So they build up those pieces of serverless purely for running, for example, their testing suites. And once the testing is done and succeeded, they basically stand up a QA cluster, deploy that version so QA can test and do their things. And then once they say, check the box, the pipeline steps one step further and says, okay, now we're going to push it out to production. And production happens to be a Kubernetes cluster as well. Right? So if you look at all the bits and pieces, you could come up with architectures like this, where everything the only things that you really build are the pieces of code in here. You don't have to stand up a SQL database. Just deploy the service, you use it. You don't have to worry about running the server clusters or the Redis cache, etc. But those were simple applications, right? And then there come the wishes from all the different users. And I've just taken kind of a fictitious application here, right? So wouldn't it be great if the application could do X? Wouldn't it be great if we could do Y? So let's look at these, right? I want to have a flexible deployment platform. Well, Kubernetes cluster. It's going to take 15 weeks to set up the cluster and make it run in production. It's not gonna. It's going to take a couple of days if we talk about a hardened managed cluster, max. If it's a development cluster, as I said, 15 minutes, it's up and running. Well, wouldn't it be great if we had vision and speech services? Of course, we could download some TensorFlow, Python, Monster, and try to figure it out, how to do speech recognition, or how to do text-to-speech synthesis. Or we could use a service that does it. You might want to guess that. We're going to see that in a second. So we might want to have some kind of edge device communication. Of course, I could try to figure out how to do WebSockets, do 15 firewalls, and allow bidirectional communication between an edge device that is hosted somewhere I don't even know and my central infrastructure. Or I could use a managed service that knows already how to do that, and I just use the APIs to say, here's my device A, here's my device B, I want them to talk to each other. Or we could use AR and VR capabilities or geospatial visualization, aka mapping. Right? And all those are services, and I've taken out 2 examples in the interest of time, which I'm already over anyway, I think. Or am I? Oh, I still have time. I'm good in time. So I've taken, because they are just cool, cognitive services and IoT Hub, right? And because, oops, sorry, that's the next one. So later on, I will need 3 volunteers already. During the demo, you can think who is gonna volunteer. Am I brave enough or not? So the first part I wanted to quickly show is, and I wanted to bring the hardware piece, but I forgot, to be honest. Let's take the example, I have an edge device that collects data. So real data, not like Dynatrace data, like temperatures and stuff, right? So I have this thing that collects data, and I want to push that data somewhere centrally. A pretty common use case these days, building services, building systems, collecting temperatures and stuff to kind of control the building. But then if you think a bit further, if it's not within my building, but if it's like spread across the globe, where I have sensors maybe connected via radio networks or via Wi-Fi networks or via cell phone networks, things can get tricky. So how do I get this thing to talk to my central data hub, where the data is stored as the basis for doing something with it? Well, I mean, I could go in and figure out, okay, what protocols can I talk, and how do I traverse firewalls and all these kind of things? Or I could just go in and say, you know, that sounds like an IoT requirement. So guess what? There is a thing called IoT Hub, which is a service that has exactly that functionality available. Communication ground to cloud, cloud to ground, auto provisioning. So I send out 1 million of these devices. As soon as they plug in, they negotiate with their mothership and say, I'm here, I'm sending something, etc. Auto upgrading of firmware. Right? I mean, these days you'll need to start regular upgrades on your fridge, for God's sakes. Right? So these are all things that, once you dig into that topic, are things that you either have to take care of by creating the capabilities, or you just use it. So what we're going to do is we're just going to see, I have registered a device here, hopefully. Yeah, just Meetup device. And all I need here is a connect string. And what that simulator does, which you see it here indicated by these couple of lines of C code, I would just go in. This is actually, it's the same, but I proved that it's actually working. You have the connect string, and then you have an SDK which is available in different languages. This is just a C example because that device actually exists in the physical world as well. So you can buy just a little toy, I want to call it. And then I run my code, which is, as you see, only a couple of lines, and it just sends fake data. And if everything goes right, down here we should see messages. And those messages are now traversing some kind of way and end up in IoT Hub in a storage account. And because there is a bit of a time delay, we'll visit the storage account later, just so I can prove to you that at least some things are working. The other example is cognitive services. And I'm just trying to figure out where I put the URLs. Yeah, here we are. So, two very common scenarios these days, and it's actually quite funny. I just got an ad on Facebook yesterday, where it's like apparently there's an app where you can read foreign language text and it returns to you how accurate your pronunciation is. Gamification kind of thing. And you will see why it's funny in a second. So, I'll not try that in German. Well, it's a good training. So, cognitive, what we have here is a single HTML page with a bit of JavaScript. So there is no massive something running behind except a serverless service. So in this example, what we can do is, this is a text-to-speech synthesis, right? So I can choose my voice that I want to use, and you see there's a couple of voices available these days. And DEAT, let's try this one. And I don't know, does the sound go through the speaker system, do you know? Okay, I'll just put it up as loud as possible.
Hallo und herzlich willkommen.
Everybody got that?
Hallo und herzlich willkommen zum heutigen Event.
It's not bad, right? So if I want to have text-to-speech capabilities, I could use that in my app. I don't have to worry about how it does it. I could even do translations.
Hallo und herzlich willkommen zum heutigen Event.
Wrong language, sorry. This one.
Hallo und herzlich willkommen zum heutigen Event.
But literally what I could do is, that's just a newer language. So literally what I could do is there's another service that allows me to do translations from one language to the other. So I could build something that uses a native newer language, takes text of language X, translates it using AI, and then speaks it out. I could even go as far as creating my own neural language. So with a little bit of time, you can go to that service. You get a text of about, I want to say, 10,000 characters or something. You read that into an audio file. You give it to the model. The model trains and returns a language that more or less fits your own. And there's actually a good demo of that from one of our corporate architects who has a YouTube video where it basically has a tutorial on kind of using those services. And in the end, he reveals that he actually never talked on that video. So basically, he had the AI read the text, and then they cut the video, and it's basically his voice. The other aspect of things, oops, sorry, wrong one, is the other direction. So if I wanted to do speech to text, right? So default microphone. Let's see if that works. Obviously, that depends on the audio quality. Let's do continuous recognition. So depending on how good the audio picks it up, I can just talk, and it will basically convert the text or the speech that I'm talking into text. And using that, what I could technically do is take that text, translate it into an English or into another language as text, and then have a neural voice speak it out in a different language. And that capability is actually built into PowerPoint if you hadn't known so far. So in PowerPoint, you will find in the presentation section, you can find an option that you can check, and I think it's called subtitles. So what it basically does is you can turn that on. You can say spoken language German, for example, subtitle language English, and if you're mic'd up to your laptop, it will basically create real-time translated subtitles while you're present. So it's not that bad. And the reason why I mentioned that it's quite funny is because there is actually an option that says pronunciation. So if I talk in English, at one point it will then tell me how accurate my English is. There is actually, yeah, thank you. 5 years San Francisco taught me. That is actually also built into PowerPoint, although I'm not quite sure if it's rolled out on all versions yet, which is the presentation coach. So basically, when you do a presentation, you can start presentation coach, and it will give you hints while you're practicing, faster, slower, speak more clearly, I can't understand you, you should go home, you're not good enough. Right? And there is tons of these services. There is vision services, object recognition services. So if you think about these kind of things, yes, obviously you can build all those things using TensorFlow and your custom models and everything. But if you want to do a proof of concept, why do you want to spend 15 hours on training something that you could just use? But then again, this service is used by PowerPoint worldwide. So it should be good enough, I guess. Okay, so we are at this stage. I need 3 volunteers. And given that the first 2 rows are empty, I can already guess that nobody's going to raise their hand. I'm not going to, first one, second one, third. Perfect. If you take a seat at these 3 boxes, don't open the boxes yet, please. Just pick one of the chairs. No worries, you're not going to be hurt too much. Okay, so I have a challenge for you guys. Each of you is playing a role of a developer who needs to build something. So we have number 1, who is the technology junkie. We have number 2, he's the good old tech guy. No, don't get too modern, we like what we know. And number 3, is the clever cloud challenger. And the challenge you are supposed to fulfill is build a duck. You have no idea what I mean by that, right? That's good. That's always the case, right? When you build something, I have no idea. But the challenge is build a duck in less than a minute. Each of your boxes has the tools for your particular role. So now, please open your boxes, see what's in there, and try to build a duck in less than a minute. Okay, I think, okay, stop. I think you guys really need help. Because our cloud challenger is way ahead of you. So let's go and introduce you to the world of serverless. So go ahead, forget your old shit and build a duck in less than a minute. Unfortunately, that only counts down to 45. That's fine. Don't bother. You're going to be done in like seconds. So whoever is done just raises their hand. See? Look how fast that is. And, oh, well. Yeah, it's been a while, I guess, right? That's good.
The cat kind of person.
That's good. But now you would think, right? I mean, they all got the same bits and pieces, right? So how can I build an individual application if everybody uses the same building blocks, right? Well, let's look at the ducks. Do they look the same? By the way, you forgot a piece in there. So it's okay. No, they look quite different, right? So it's really a matter of putting pieces together the way you need them. Thank you. I think I made my point, but wait here for a second, because... And now everybody's going to be, shit, I should have volunteered. Because obviously, these things, well, you can keep the ducks, but the other things I'll take back. But there's a little thank you for your... That's fine. I don't care.
Thank you. Thanks. Thanks a lot.
Sure. So, really the point I was trying to make, right? Get creative. Don't dismiss serverless or PaaS services from the get-go saying, this is not flexible enough, right? They all had the freaking same pieces of Lego. And each duck looks differently. In the same way you can build applications using PaaS services, using serverless technology, and they will still look different. Because ideally, what you would do is take your services and just build what needs to be built to go in between. Yes! And here we have a bug. And with that, I think I'm still 2 minutes over. But I'm opening it for Q&A. Although, since we are anyway networking, we don't have to have a formal Q&A now. Feel free to catch me, grab me, pin me down, beat me, whatever you want. And I will hopefully be able to answer your questions. Thank you very much. There's my contact information. And if you want, contact me via LinkedIn. Now you can applaud.
Can I borrow your laptop?
For what?
For Google.
For Google?
Yeah, just for a random...
As long as it's not
random
GCP,
number.
yes. Yeah, of course.
Just